distraction is defined as a thing that prevents someone from concentrating on something else. Researchers have found that rather than being laser-like, attention is actually more akin to a spotlight that continually dims and comes back on again. The research, conducted on humans and macaque monkeys, concludes that our ability to focus is designed to work in bursts of attention, rather than uninterruptedly. For instance, while it may seem that you are continuously focusing on this presentation, the reality is that you're zooming in and out of attention up to 4 times per second. The researchers found that in between those bursts of attention, we are actually distracted. During those periods of distraction, the brain pauses and scans the environment to see if there is something outside the primary focus of attention that might be more important. If there is not, it refocused back to what you were doing. The brain can't process everything in the environment, explains Ian Fibelkorn, an associate research scholar at the Princeton Neuroscience Institute and one of the authors of the paper. It's developed those filtering processes that allow it to focus on some information at the expense of other information. The reason why we are not aware of those gaps is because the brain tricks us into perceiving reality as a continuous movie. This is a remarkable finding that links back to the old debate of whether perception is continuous, says Sabine Kastner, professor of psychology and leader of the project. The way we perceive our sensory environment seems to be. But our findings show that this is subjective. What really happens is our perceptions go through rhythmical changes. The studies show, for the first time, that these rhythms correspond to the alternation between 2 different brain states, one that is associated with focus and one that is associated with distractibility. At the peak of a brain wave, our perceptual sensitivity is at its lowest, while the trough of the wave corresponds to our highest ability to focus, the moment when we are most capable of processing the information in our environment and reacting to it. So why does our brain make us go through attention pulses at such a fast rate? The researchers suggest that it corresponds to an evolutionary advantage. Think about when life was more dangerous, Fibelkorn says. You would have to constantly be on the lookout. You would want to always be aware if there was something around you with bigger teeth. In modern life, this particular feature of the brain allows us to realize, for instance, that a car is coming as we are crossing the street. Our spotlight of attention, in this sense, has been and still is key to our survival. This trait is not exclusive to humans. Studies on macaque monkeys showed almost identical findings, suggesting that this rhythmic form of attention is potentially common to many other species. Human performance at low levels of workload is not particularly good. Work under load is where a job is routine, repetitive and understimulating. Underload also induces boredom, which may create a lack of motivation and a loss of skills, and can lead to errors, with individuals being less alert and more prone to distraction. Thus, at low levels of workload, underload errors typically take the form of missed information due to individuals not taking in information from the environment around us. As the demands of the task, or the workload, is increased, the standard of our performance increases until an optimum level of workload and performance is achieved. Any increase in workload after this point will lead to a degradation in performance. Too many tasks to complete in the available time, tasks are too similar and easily confused. Conflict between the type of tasks required. At extremely high levels of workload overload, important information may be missed due to the narrowing or focusing of attention on only one aspect of the task. When a driver pulls into a busy station with a number of signals and points in unusual track conditions, workload increases and attention can become more focused on the core task information available to the driver, such as the signal aspect in front of them. This means the driver may be less able to detect changes in the situation around them. The human information processing model can help us to determine the source of overload. It may be that the task is too difficult, for example, the amount of information to be perceived in order for a decision to be made is beyond the attention capacity of the human. Alternatively, there may be too many responses to be made within the time available. While it is possible to do 2 things at once, Dividing our attention between two separate activities does increase the potential for error, as we are prone to become preoccupied or distracted with one of the activities, leaving the other activity unchecked. Driving a train involves many tasks that have to be performed at the same time, such as checking signs, target speeds and warning devices, all of which cause attention to be focused away from checking the signal. Research into the dynamics of visual attention suggests there is a possibility that, with everything a driver has to look at, sooner or later a signal will not be attended to. Our attention to a task can be impaired by our natural response to react to more attention-grabbing external features in our environment, such as alarms, a loud bang, telephone calls, colleagues, other work-related equipment, environmental stressors, heat, light and noise, or by something which suddenly appears in our field of vision. Safety incidents, including SPADs, occur when a distraction of some kind is more attention-grabbing than the core task information. Example: signal, line side, speed, distance, at a time when it is safety critical that the driver attends to the core task. An example would be a driver becoming distracted by a passenger walking across a footbridge and being oblivious to a changing signal aspect. Social influences are considered in relation to having more than one person in the cab. Two people can be a distraction in that some drivers may feel a perceived lack of control over what that other person might do. Some feel it is an invasion of their personal space, or feel the presence of another contributes to their workload. On the positive side, a second person may add variety to an otherwise monotonous activity, can provide support, and may cause the driver to drive more safely if they feel they are being evaluated or because they want to prove their ability as a safe driver. Preoccupation is another form of distraction and can be caused by issues specific to the individual, such as problems at home, financial difficulties, or work problems. When attention is directed to internal thoughts, for reasons such as dissatisfaction with work, work-related events, and/or domestic concerns, all of which cause intrusive thoughts, more attention resources than normal can be allocated to them. An individual may not just be preoccupied with negative issues. Events that an individual is looking forward to, such as the birth of a child or an imminent holiday, can be just as distracting. A working environment contains environmental stresses such as lighting levels, noise, temperature, and vibrations. These can lead to feelings of discomfort and act as distractions which will impair an individual's performance. Lighting, or more specifically overlighting or glare, can cause distraction and visual fatigue, as well as physical discomfort for some types of glare. Noise makes performing tasks more thoughtful, perceived mental workload increases, and tolerance reduces. Temperatures lower than 0 degrees or higher than 32 degrees have produced reductions in manual and mental performance. The design and layout of the working environment is also essential for optimum safety performance. Work areas and operating positions should be arranged so they allow for free movement, safe access and egress, unhindered visual sight lines, and reaching distances to primary equipment. If drivers become distracted and need to bring their attention back to the core task, or if they have been running on mental autopilot for some time and want to come back into a state of conscious control, there are some simple strategies which can be used to refocus thoughts on the task in hand. There are a set of simple questions they can ask themselves. What color was the last signal? Where precisely am I on my route? Where is my next signal? When should I be slowing down? Am I traveling at an appropriate speed regarding speed restrictions and external conditions? Are there any unusual circumstances? In addition, review any changes to the norm, for example, temporary speed restrictions. Check automatic warning system. Special stop orders. Work being carried out on the track. In conclusion, try to see what is most suitable for you. Don't overload yourself with tasks whilst following restrictive signals, entering or leaving the platform. Techniques as risk trigger commentary, press call react, pause for doors, verbalization and target fixing are there to help you focus on the task at hand.